Okay, today is about quadratic inequalities. First of all, is this a quadratic? No, it's not a quadratic. It's a what? It's an absolute value. Okay, so you're going to have to know both. So even though the title of this lesson is quadratic inequalities, let's make sure that you understand the difference between this and an equality. This says equals. If I make it less than or equal to, for example, that'll make it an absolute value inequality. If this problem had been something like this, that would be a quadratic inequality because it's quadratic because it's got the squared in it, and an inequality because it's not set equal to. All right. So just a blast from the past, you should be able to solve this kind. You subtract 5 from both sides, and you get 3x minus 4 is less than or equal to 3. And then I'm going to divide by 3. And then I have absolute value of x minus 4 is less than or equal to 1. Have I needed to change the signs at all? Nope. Didn't need to change signs ever because I never multiplied or divided by a negative. If I had, I would have switched this sign to be a greater than instead of a less than. Now I'm going to divide it into two parts. X minus 4 is less than or equal to 1. And x minus 4 is, because I'm changing this 1 to a negative 1, then I'm going to change the sign to greater than or equal to. Then I would add 4 to both sides of both equations. X less than or equal to 5. X greater than or equal to 3. Now, if I actually put that on a number line, it helps me anyway to really see what I'm doing. It can be 3, and it can be bigger than 3. That's from this one. And this one says it can be 5, or it could be less than 5. And there we go. It's in between 3 and 5. So there's actually a range of answers that would work. Oh, sounds like I made a mistake. Okay, so in the problem, right away I changed it to a less than or equal to 8. So then, yeah, if you're back to 10 minutes ago where I did the problem, it's just an equal sign, of course it'd be different. These would just be equals, and then you just have two answers, 5 and 3. It'd be done. But I changed it to a less than because the title of this unit, I was trying to blend a review of the past ones we've done with this new stuff. The new stuff is about inequalities. So now it's got these signs, and therefore you're going to get a range of answers. Kind of like if I just said x is greater than 10 as my answer. There's a lot of answers. 10 works, 11, 12, 13, 14. But this, only the numbers between 3 and 5 work. If my life depended on it, I was nervous for a second I'd screwed up because I saw a hand go up kind of quick like that. If I needed to be sure I was right, do you think I can just check by sticking in a number like 4? And 4 is supposed to work, right? We just see if 4 does work. Put in a 4 here. That works kind of nice because this will make 0. 3 times 0 is 0. And it just says 5 is less than or equal to 8. Is that a true statement? Yeah, it is. So it worked. And then I'm saying that things out here don't work. So things like 6 are apparently not going to work. So if I stick in a 6, it gives me 6 minus 4 is 2. 3 times 2 is 6. 6 plus 5 is 11. Is 11 really less than or equal to 8? No, it's not. So, yay, I was right. This little zone seems to work. If I really wanted to be extra careful, I would probably check a number smaller than 3, like 2. If I stick in 2 here, 2 minus 4, absolute value of negative 2, which is 2. 2 times 3 is 6, plus 5 is 11. Is 11 less than or equal to 8 again? No, still doesn't work. So cool. Doesn't work on either end. Does work in the middle. And that's how you can tell you're doing them right. Now, that same process is exactly the same if you have a quadratic. Let's get a really simple one here. Why is that a quadratic? Well, first of all, it's got an x squared in it. Okay, and I've told you before that if you can factor it, you should. To have a chance of factoring this thing, we should probably put it all over on one side by subtracting 16 from both sides, and I have x squared minus 16 less than 0. Why'd I do that? Because you always want to set your quadratics equal to 0. Or in this case, greater than or less than 0. So get it that far. Catch up to me, please. Then, if you can factor it, you should. Otherwise, you're going to have to use the quadratic formula to find your zeros. I'll pause for a minute while you factor that thing. So you say it's x plus 4 and x minus 4 is less than 0. Excellent. Now, here's the moment where it gets a little bit weird. Even though I don't want it to be equal to 0, I want it to be less than 0, I still need to find out the places that it would make it equal 0. Because those will be the important spots on the number line. Just like before, and I think you guys all know it's going to be negative 4 and 4 that are the things in the number line. But how did I get that? It's because I needed to know if this was an equal 0, what are the answers? Negative 4 and 4. And then that tells me my zones. Okay? And now if I know now that this is negative 4 and this is 4, then I got to start checking those spots themselves. Do those spots themselves actually work? If you don't know, plug them in. But then do the shading in the right spots. And then all I'd ask at the end is that you write your answer as an interval. You may recall that this form is the number line form of the set. There's also set builder. Just be happy I'm not asking you for that. But there's also interval notation. Figure out where this thing works. Is it in between them? Is it on the outsides of them? Does the 4 work? Does the negative 4 work? And then give me your answer as something like this. That is not the right answer, but something like that. I'll pause for a second while you try that. Okay, the answer was definitely not from negative 4 to infinity. First of all, do you guys think that negative 4 itself worked or not? When you put in negative 4, it turns this whole thing into 0, which turns this whole thing into 0. Is 0 less than 0? No, since it just said less than. If it had said less than or equal to, I'd have filled it in. I hope you're noticing a theme there. This is just like simple ones where if it was like x is less than or equal to 5, you'd fill in the 5. Well, this is empty circle, and then I got to test other areas. Again, could I solve this by saying x is greater than 4 and x is less than 4, that kind of stuff? Sure. But it's also valuable for you to know that you can just stick in a 5, see if it works. If I stick in a positive 5 here and here, I get a positive number and a positive number, and that has to be bigger than 0, doesn't it? Notice I didn't even need exactly what the answer was. Oh, less than 0. Sorry, thank you, that's a less than. I have a positive and a positive, and if I'm multiplying two positive numbers, no matter what they are, it's going to be positive, which is not less than 0. So it doesn't work out there. Now let's pick something in here. 0 is a really easy thing to stick in. So I'm going to stick in a 0. I'm going to clean this up a little bit. It's getting a little messy. Get all that stuff out of here. Get this down here. If I now stick in a 0 to test this region, this turns into 4 times negative 4 is negative 16. Is negative 16 less than 0? Yeah, works. So it works in here. And then lastly, out here. Out here I have a negative 5. If I put in a negative 5 here and a negative 5 here, I'm getting a negative times a negative, which makes a positive. Is a positive number bigger than, or no, less than 0? No, it's not. So that's out. All right, one more thing, and I think this could blow some minds. Get it worked in between? The answer was in between negative 4 and 4. So if I was going to write that as a interval, I could say from negative 4 to 4. It worked, but didn't work on either end. Watch what happens when I graph it. Would you agree this is a U-shaped parabola? Because there's no negative out in front of it. It's got to be right side up parabola. If I just look at the picture of the graph that I just made, do you get where the graph is less than 0? It's in this little zone right between here and here, isn't it? That it's less than 0. So if you look at it as a picture, it's so much easier. Can you see where that graph is less than 0? Yeah, in that little zone right there between negative 4 and 4. You get where I'm going with this? Let's say that's your function. Let's say I said, when is that function bigger than 0? This spot's important. Say it's negative 3. Say that's positive 4. Let's say that's positive 8. then I would say that this function is bigger than 0 between here and here. And that's between -3 and 4. And it's also bigger than 0 from 8 on. Those are the regions where it's bigger than 0. It's good to think of these as pictures because when we start doing this, life gets really complicated if you're just going to do it algebraically. But if I need to just figure out where is this picture, where is this picture, where is this picture less than or lower than this picture, it won't be hard at all. Okay, so where is x squared plus 3? Would you agree generally it kind of looks like that? It's parabola shifted up a little bit. Okay. And then where is the absolute value of x minus 4? Well, that's a V shape. That's been shifted which way? To the right 4. Do you agree it's something like that? Okay. Where is the parabola less than or lower than the absolute value? Here's the parabola. Here's the absolute value. Do you get in this little zone right in here that the parabola is underneath the absolute value? It's lower than it. Now, if I extend this out, maybe this will get, I think this one, as this gets wider and wider and wider, and this one's going to follow a straight line course, I don't think they will ever intersect again. So I think always, at any point, like say here, I follow it up, the parabola is lower than the absolute value. So it's only at this moment where they touch, that spot's the only moment where they're equal to each other. Otherwise, all the way from here to here, so from negative infinity until wherever they touch, would be the answer. All right. I need to give you another one that's even simpler, because I'm seeing a lot of confused faces. How about this? Y equals x squared. Make a quick sketch of that. Okay, got that? All right, now let's do an upside down absolute value. Let's make y equal to negative absolute value of x, but let's make it shift up a little bit, plus 4. Drawing what that looks like. An absolute value that's been flipped over and moved up. Raise your hand if you had something like that. Okay, good. Would you agree that there are some places where the parabola is higher than the absolute value? Like if I pick this moment right here, at x equals, let's say, -3 or whatever that is, the green one is way lower than the blue one is. So the absolute value is under the parabola at that moment on. In fact, this pink line, I'm just picking a capricious, just a spot that really didn't matter, just a random place. If I pick this random place, I can tell the green one's higher than the blue one. But what are the important spots? Where they touch. At that moment, they are equal. Could we solve to figure out where the one is equal to the other? Yeah, that would be where is x squared equal to the negative absolute value of x plus 4. Solve. Find, there's two answers. We know there's two answers. I can see them. Figure out how to solve that thing for x. Remember, it's an absolute value, so it's got to break. That's what's going to break it into two equations. Hint, start by subtracting 4. I'll pause for a second while you figure this one out. Did anybody get it that far where you get absolute value of x alone and then you get negative x squared plus 4? All right, good. Then I need to split it into two equations. First one is just without the bars. So I'm going to lead with the x equals negative x squared plus 4. You could write it in the other order and that would have been fine. And then x equals, and then you do the opposite of what you just wrote a second ago. Notice I have parentheses around the whole thing. Negative x squared plus 4. Now to solve this one, I'm going to add x squared to both sides. That'll make it x squared plus x is equal to 4. Then I'm going to subtract 4. X squared plus x minus 4 equals 0. And then I can solve that quadratic. And then over here, I have x equals x squared minus 4. So in this case, I'll say 0 equals, I'm going to subtract x from both sides. X squared minus x minus 4. If you can factor it, you should. How do I factor that 4 so that I'll have a 1 term in the middle? I don't think, can you factor that? I don't think you can factor that. So what do you do if you can't factor? Can factor, you should, and here's the follow-up to it. If you can't factor it, use the, nobody? Quadratic formula, good. And that'll tell you the two answers here. And this one also, I'm pretty sure, cannot factor. And therefore, I'd use the quadratic formula. All right, I'm not going to make us chase this down any further, but that's how intense this section can be. What are the main themes? First of all, if I give you a picture, you're going to be good at it. So if I don't give you a picture, you should make a picture. Let me just make sure my theory that you'd be good at it if there's a picture is actually true. Say I have this. And say I have that. And say that, obviously I'm trying to make them hit right there at x equals 0. And the other spot they hit is at x equals, let's say that's 5. That spot and that spot are obviously important. Can you tell me where is the parabola is greater than or equal to the absolute value? That's hard enough in itself. But if you see the picture and you know greater than just means bigger than, it's not that hard. Where is the parabola bigger than the absolute value? I'm going to pause while you write down what you think that is. And your homework for tonight is, I am just going to have you do the first 2 pages, once it says assignment on it, do the first 2 pages of the assignment. And that's all I got for you for today. Okay, and the ending to that question, where was the parabola greater than the absolute value? It was in this zone. The parabola was greater than the absolute value. That's from negative infinity up until 0. And there's another zone where the parabola was bigger. It's over here. And that's from 5 to infinity. That was tough. I think you'll find the homework isn't that tough. But I went through some of the toughest kind with you. That's all I got for you for today.